Alright, this video is going to be pretty much just a probability review. I'm going over all four topics that will be covered on the test. The first being Venn diagrams, the second being overlapping events, the third being independent and dependent, and then conditional probability. So, Venn diagrams. We are going to construct our own Venn diagram right here, and we're going to do it just from these sentences above. So, there are 500 freshmen, so I need that number. That is going to be my total number. I know this whole population has got to be 500. Of those, 300 take math. So I know that this circle out here for math is going to be 300. This whole thing is worth 300. This whole science bubble is worth 250. All right. So right now y'all are maybe thinking 300 and 250, well that's already more than 500. But we have to remember that there is an overlap between these two guys, which hopefully will make sense as we go through it. So 200 take science and math. So let's get 200 in there. All right. Now that is part of math and it is part of the science. So we need to determine what does this value need to be in order to make this whole circle 300? Well, we should see that that should be 100 because 100 and 200, those add up to 300, so I'm good on math. And then 200 plus some number will give me 250. So that gives me 50. It asks how many students are not in math and science. So math or science would be everything outside of here. So a real life example would be English and history. So what students have English and history but don't have math or science? Well, right now we're accounting for 100 plus 200 plus 50. So 350 students have math, science, or both. So that leaves this outside area must be 150 students. Okay, so if it was asking for a probability, I would say 150 out of 500 do not have math or science. So that's how we would construct a Venn diagram. Always start from the inside and work your way out. Okay? Next topic, overlapping events. All right, this table is in reference to this first question has nothing to do with this table, so let's move that down so we don't get confused. We'll even cover it up. In a deck of 52 cards, what is the probability of drawing a face card or a club? So I highly recommend that first thing y'all do is write out what it is saying. Probability of a face, and the key word there is or, so we're going to put our or symbol, or a club. Okay. Hopefully, if I haven't said this in class enough, I'm going to say it again. When it's or, we add. Okay. Probability of a face card. Well, there's a jack, a queen, and a king in each suit. And there's 4 suits. So there's going to be 12 total face cards, 12 out of the 52. Plus, there are 13 clubs, 13 over 52. But are there any face cards that are clubs? And we should say, yeah, there's the jack, the queen, and the king of clubs. So let's subtract those 3 cards. And my answer will simply be 12 plus 13 minus 3, which should be 22 over 52. Okay? That's how we would do a word problem. I highly recommend that you write it out like this rather than just try to read it off the question. All right, when we're involving a table, all right, totally new problem, has no relevance to the cards. We got a table of soccer, tennis, and lacrosse players, boys and girls. So first thing we should do is add these up. So this is going to be 33. This thing's going to be 23. Lacrosse will be 38. All right, the number of boys that we have is going to be 48. And the number of girls that we have is going to be 46. All right, so when I add all these up, my total number will be 94, and that's true if I add these or I add those. Either way, it's going to be 94. All right, so it's asking for the probability of being a soccer player or a girl. So when it's or, we add. Okay, we're going to do a soccer player. Probability of being a soccer player is 33 from this number right here. 33 over 94. And the probability of being a girl, 46 out of 94. But were there any girls that played soccer? Yes. 18 girls that played soccer. And I'll show you why we want to subtract that. We want to subtract that 18 over 94. We want to subtract that because I count my soccer players, so that's this, and then I count my girls. What is the only box that was counted twice? You should be seeing that it's that 18. So we don't want to count it twice, so we subtract that off there at the end. All right, and this is going to equal 61 over 94, and that is the probability for a person playing soccer or a girl. All right, hopefully we understand overlapping events. Independent and dependent. All right, so I'm drawing some candy out of a bag. All right, I want to know the probability of getting a Snickers and then a Reese's without replacement. Whenever you see questions like this on the test, go ahead and underline without replacement, because that is a big deal. We're not putting it back in the bag. All right, so I want to know the probability of getting a Snickers and a Reese's. All right, so when it is and, we want to multiply. Okay, that's a dot. Not a good dot, but it's a dot. All right, so we want to find the probability of a Snickers, which total amount of candy that I have. All right, 30 and 45 are 75 plus 24, that's 99 pieces of candy. So probability of a Snickers is 24 out of 99. And because we are not replacing it, my probability of getting a Reese's is 30. And because it was not replaced, I have one less piece of candy in the bag. So it's going to be 24 over 99 times 30 over 98. So let's multiply this out. And it should give us 0.074, something in there as our probability. Okay, so don't forget when we subtract, when it's without replacement, we're taking one away. All right, last thing, conditional probability. We want to use this formula up here. A given B, the second number, second letter will always go underneath right here. Okay, so the probability of A and B, which in this case is, it already gave it to us, is 0.20, divided by the probability of B. All right, it's as simple as that. Whoops. Don't know what it is. Okay. Let's use that same table. So hopefully we understand that. If it gives us A, it gives us B, and it gives us A and B, just plug them into the equation. Okay? And that's on our EOC sheet. So that one will be given to us. So let's use the table from before to determine tennis, given that that it is a girl. Okay, so given it is a girl, so that means I am focusing in on only the girl area right there. Okay, so we can see that we are focusing in only on the girl section, which adds up to 46. Okay, so let's get 46 in there. All right, and because I'm only focusing on the girls, now since I'm only in there, I'm only worried about the girl column. So we can even box it off. Okay, so and how many play tennis inside of the girls? Well, there's 12 out of the 46. Okay, so in a chart, it's a lot easier. When we don't have a chart, we've got an equation that we can plug it into. hopefully this helps, and hopefully I've addressed the 4 topics that you have questions on, and looks like we've covered everything and we'll be good to go tomorrow.